Hello students, welcome to the e-learning platform presented by Mechanical Engineering Department of Dr. Bapuji Salke Institute of Engineering and Technology, Kolhapur. The learning objectives for today's session are number 1, study the laws of thermodynamics. First law of thermodynamics and second law of thermodynamics will be studied in today's session. Second, study the properties of steam. The different types of steam and properties of the steam will be studied in today's session. Starting with first law of thermodynamics. The first law states that work transfer is equal to heat transfer and does not place any restriction on the direction of flow but reversal of the process, that is heat transfer to work transfer is not possible. The first law of thermodynamics states that the total energy of an isolated system is constant. Energy can be transformed from one form to another but can neither be created nor be destroyed. According to this law, some of heat given to the system is used to change the internal energy while the rest is doing work by the system. According to this statement, first law, the potential energy can be converted into kinetic energy and kinetic energy can be converted into potential energy. But in natural practice, this does not happen. The principle of conservation of energy leads to the first law of thermodynamics. The principle states that the energy cannot be created nor be destroyed, but it can be transformed from one form to another form. According to this law, when a system undergoes change of state, both heat and work take place, or both heat and work transfer takes place. The net energy transferred is stored within the system and is known as stored energy or total energy, mathematically given as delta U, delta Q is equal to delta U plus delta W, where delta Q is heat supplied to the system, delta W is the work done by the system, and delta U is the change in internal energy of the system. The first law of thermodynamics states that energy can not be created nor be destroyed but can be transformed into one form to another form, based on which the equation mathematically we derive delta Q is equal to delta U plus delta W. If the Q is positive, that is the heat energy is positive, then there is net heat transfer into system, whereas if W is positive, that is the work done is positive, then there is the work done by the system. So positive Q adds energy to the system and positive W takes energy from the system. This can also be represented as delta U, that is change in energy, can be given as delta Q minus delta W, that is change in energy is given by a change in heat transfer minus the work done. There are some limitations of this first law of thermodynamics which are discussed as number 1. The limitation of first law of thermodynamics is that it does not say anything about the direction of flow of heat. That is, it does not say anything about the direction of flow of heat. म्हणजेच हीट कुठून कुठे फ्लो होते, फ्रॉम अप्पर बॉडी टू लोअर बॉडी, from lower body to upper body, or from upper body to lower body, it is not mentioned in this first law of thermodynamics. It does not say anything whether the process is spontaneous process or not. म्हणजेच प्रोसेस तुमची कंटिन्यूअस आहे, स्पॉन्टेनियस आहे काय नाही ह्याच्याबद्दलही हा फर्स्ट लॉ काही सांगत नाही. द रिव्हर्स प्रोसेस इज नॉट पॉसिबल. वी नो दॅट द रिव्हर्स प्रोसेस इज नॉट पॉसिबल. इन ॲक्च्युअल प्रॅक्टिस द हीट डज नॉट completely convert into work. We know the heat does not convert completely into work. If it would have been possible to convert the whole heat into work, then we could have drive the ships across the ocean by extracting heat from the water of the ocean. To overcome the limitations of first law, the second law of thermodynamics. There is second law of thermodynamics. Second, to understand the second law of thermodynamics, consider example that if you ever drop a glass and watch it shatter, you know there is no way of going back in time and getting back the unbroken glass. This is called as irreversibility. म्हणजेच एखादा ग्लास काचेचा ज्यावेळी आपण फोडतो त्याचे तुकडे होतात, तर असली कोणतीही पद्धत नाही की ते आपण ती तुकडे परत जोडू शकतो. ह्या परत जोडण्याच्या प्रोसेसला इरिव्हर्सिबिलिटी असे म्हणतात. द सेकंड लॉ ऑफ थर्मोडायनामिक्स स्टेट्स दॅट द हीट एनर्जी कॅनॉट बी ट्रान्सफर्ड फ्रॉम अ बॉडी ॲट अ लोअर टेम्परेचर टू अ बॉडी ॲट अ हायर टेम्परेचर विदाउट ॲडिशन ऑफ energy. The second law of thermodynamics states the heat energy cannot transfer from body at a lower temperature to a body at a higher temperature without the addition of energy. This is why the air conditioner for a long period of a time running cost you money. म्हणजेच the heat energy, transfer of heat energy from lower temperature to higher temperature is not possible without the addition of energy. In second law of thermodynamics, there are two statements given. The first is Kelvin-Planck statement. The Kelvin-Planck statement states it is impossible to construct an heat engine working in a cyclic process whose sole effect is to convert all heat supplied to it into an equivalent amount of work, or it is impossible to convert all the heat extracted from a hot body into work. In heat engine, the working substance takes heat from the hot body, converts a part of it into work and gives the rest to the cold body. There is no engine that can convert all heat taken from the source into work without giving any heat into sink. This means that for obtaining continuous work, the sink is necessary. The application of second law of thermodynamics is in automobile vehicle, in electric generations. The fuel burn in cylinder of IC engine develop, that is internal combustion engine, develops heat energy which is transferred to move the vehicle on road, but some of energy is lost in friction and cooling medium. Hence, the solo effect, that energy developed inside the cylinder, is not completely utilized to perform the work. The second statement is Clausius statement. The Clausius statement says it is not at all possible to transfer heat from a cold body to a hot body without the expenditure of work by an external energy source. That is, it states it is impossible for a heat energy to flow from a body at a lower temperature to higher temperature without the help of an external work. It is also the same as the Kelvin-Planck statement. These are the two second law of thermodynamics statements stated by them. One, Kelvin-Planck statement, and second, Clausius statement. Next is properties of steam. Steam is nothing but vapor used as a working substance in the operation of steam engine and steam turbine. Steam is a mixture of dry steam, that is gas, and moisture, that is water particle. A pure substance is defined as homogeneous material which retains its chemical composition even though there may be change of phase. Pure substance exists in three states as we know, that is solid, liquid and gas. Each state is known as phase. When the solid is when the solid is heated, it turns into the liquid, and when liquid is heated, it turns into the gaseous phase. This gaseous phase is where there is mixture of gas and moisture is called as steam, and when the gas is cooled, it is obtained to the liquid, and when liquid is cooled, the solid phase is obtained. There are three types of steam. The number one, wet steam. Wet steam is when the steam contains some water particles in suspended form. It is known as wet steam. The suspended water particles are known as moisture. The suspended water particles are known as moisture. The wet steam is a mixture of two phases, that is liquid and vapor. The temperature of wet steam is the saturation temperature at given pressure of steam. Second, dry steam. Dry steam, when steam contains no moisture, it is called as dry steam or dry saturated steam. The temperature of dry steam is saturation temperature. And the last is superheated steam. If dry saturated steam is heated, or if dry steam is heated, its temperature starts to increasing. This higher temperature of an steam is known as superheated temperature, given by T. Su. The difference between the superheated steam and the dry steam is known as degree of superheat. The superheated steam have no moisture content, and this type of heat is used for energy generation purposes. The last point, that is the dryness fraction. Dryness fraction is a term for wet steam. Wet steam contains some moisture, thus dryness fraction is defined as, which gives the indication regarding the dryness of the steam, or the amount of dry steam in 1 kg of wet steam. Dryness fraction is nothing but the amount of dry steam in 1 kg of wet steam. It is denoted by X. X is equal to Ms upon Ms plus Mw. That is, Ms is equal to mass of dry steam, whereas Mw is equal to mass of moisture present in a steam. If 1 kg of wet steam contain 0.8 kg of dry steam, then the dryness fraction X is equal to 0.8. If steam is 30% wet, then the dryness fraction is 0.7. For saturated steam, the dryness fraction X is equal to 1, and for saturated liquid, the dryness fraction is equal to 0. Superheated steam does not contain dryness fraction. So this is it. Thank you. In today's session, we have completed first law of thermodynamics, second law of thermodynamics, concepts of wet steam, superheated steam, dry steam, etc. Thank you.